This video is going to cover the ions in solution practice page. So in this practice, or on this practice page, you have two beakers, okay, where you're adding silver nitrate and potassium phosphate. The first direction is to draw a picture of each beaker showing what solutions and ions are in the beaker. So one of our first beakers, okay, has 150 milliliters of a 0.200 molar solution of AgNO3. Okay, so in this particular beaker, you should have Ag plus ions and nitrate ions. In the second beaker, you have 100 milliliters of 0.300 molar potassium phosphate. So in this particular beaker, since potassium is a 3-to-1 ratio, you have 3 potassium ions for every 1 phosphate ion. Oops, that should be a 4. Okay? Sorry, this should be K3PO4. I guess if you watch this video, you can have plus 30 points. Okay? So, those are the two beakers. Okay? Question B says, okay, now these two beakers are mixed, so draw what would be in the final beaker. And this is really something you should be able to pick out. We should be able to pick out what exactly reacts just by looking at these two things. Okay? We should know that all nitrate ions are soluble and all potassium ions are soluble. So there should be potassium ions and nitrate ions left floating around. And then what we should be able to see is that the silver ions should be reacting with the phosphate ions. So I should get down at the bottom some silver phosphate solid. Okay? Now, because this is a reaction, there actually may be leftover phosphate or silver ions in this beaker. We don't know that yet, but there is possible leftover silver or phosphate. We're not sure what might be left over yet because we haven't done the reaction, but one of those two ions could be excess. Okay? So, that's what is in the beaker. The next question says to write the molecular and ionic equation. So the molecular equation is going to be the silver nitrate, which is aqueous, plus the potassium phosphate, which is aqueous, should equal potassium nitrate, which should be aqueous, plus the silver phosphate, which should be solid. And then we need to do a little bit of balancing. So I'm going to need a 3 here and a 3 there, and that should balance me out pretty well. Okay? Then it says write the net ionic equation, and because we know that that is our solid, we should be able to pick out the net ionic equation fairly quickly, and that should be 3 Ag plus PO4 3 minus yields the Ag3PO4 solid. Okay, so that should be our net ionic equation. So now, letter D wants us to determine the mass of the precipitate. Okay, well, this is where we are going to need to make our mice chart. Okay, I'm going to move this up a little bit. Okay, so we need to make a mice chart, and that means we need to figure out how many moles of silver we have and how many moles of phosphate we have. Now, those two are going to come from our initial concentrations. So if we go back and look at AgNO3, okay, remember we had a 0.2 molar solution, so we had 0.2 moles of AgNO3 per liter, and we had 150 milliliters of that. So we can calculate this out to be the fact that we have 0.03 moles of AgNO3. Okay? And because in AgNO3 everything is a 1-to-1 mole ratio, okay, we would know that we have 0.03 moles of Ag. Okay? Then we want to find out our moles of phosphate ions, and that's coming from the potassium phosphate. Okay? And if we go back to the initial directions, we have 0.3 molar solution of potassium phosphate. So that's 0.3 moles per liter. And we had just 100 milliliters of that, which is 0.1 liters. So that gives me 0.03 moles of K3PO4. Okay? Now, this is a 3-to-1 mole ratio, but all I care about is the phosphate. So I'm going to have 0.03 moles of the phosphate. Now I have none of this to start with. Okay, now you have an interesting dilemma because we are not 1-to-1. We are 3-to-1 in terms of our mole ratio. So we cannot just assume that all of the silver or all of the phosphate leaves. So we need to do a quick side calculation of some stoich to figure this out. And I'm going to kind of assume that the silver is the limiting reactant. So I'm just going to find out how much phosphate we need for that silver. So if I have 0.03 moles of silver ions, and I have a 1-to-3 mole ratio, okay, what that's going to tell me is that I need 0.01 moles of the phosphate ions. So all of the silver ions will disappear, but only 0.01 moles of the phosphate ions will disappear. So that's going to leave me with 0.2 moles when I'm all said and done. Now, that also means, because this is a 1-to-1 mole ratio, then the phosphate ions are going to be 0.01 moles. So I have 0.01 moles of silver phosphate. So ultimately, that's what I need, because if I want to find out what the mass of the precipitate is, this right here are the moles of the precipitate. So I'm going to take that and use that to find the mass. So I have 0.01 moles of Ag3PO4, and I'm going to multiply that by the molar mass of Ag3PO4, and when I do it, I get 418.6 grams of Ag3PO4 per every 1 mole. So that gives me 4.186 grams of Ag3PO4. PO4. Okay, so this right here is the mass of the precipitate. So that would be letter D. Okay, now, some things to go back and look at here. Okay, with my MICE chart right here. So with this MICE chart, what we want to look at is what ions are left over. And what you see is you have phosphate ions left over. So I apologize for sliding up. But if I go back to this beaker, okay, when I said I might have silver ions left or I might have phosphate ions left, what I have left in the beaker are phosphate ions that did not get used up. So now, because I drew this beaker out, I can answer the next question. It says, determine the ions left in the solution. Well, the ions left are potassium, nitrate, and PO4 3-. Okay? Now, the next part says determine the concentration of the ions left. So I'm going to need more space for this, so I'm going to move down. Okay? And so what we've determined is we have potassium ions left, nitrate ions left, and phosphate ions left. Okay, so those are the 3 ions that we have left. What we need to know is what are the moles of these. And we calculated these earlier. Okay, so for the moles of the potassium ions, those came from the K3PO4 solution. Okay, and I'm going to go back up here, and I'm sorry to do this to you. Okay, so our potassium ions are coming from this solution, which we calculated, here, okay? So we calculated the moles of K3PO4 right there, but you need to be a little bit careful because there's 3 of them, so it's a 3-to-1 ratio. So I have 0.09 moles of potassium ions. Okay? My nitrate ions came from right here, and that's a 1-to-1 mole ratio, so I have 0.03 moles of those. And then my phosphate ions are coming from right here, and I have 0.02 moles. Okay, so those are the moles that we have. And then what you have to look at is, in order to find molarity, molarity is moles per liters, I need to know, okay, how many liters have I got? And if you go back, okay, we had 150 milliliters of one, and we had 100 milliliters of the second one, so we have 250 milliliters as my volume. So what I'm going to need to do is I'm going to need to divide all of these by 0.25 liters. And if I do that for my potassium, that comes out to be 0.36 molar. If I do this for my nitrate, that comes out to be 0.12 molar. And if I do this for my phosphate, that comes out to be 0.08 molar. So we have now found the concentration of all the ions.